Okay, we are going to build on what we learned about how to solve by taking a square root, and we're going to use the quadratic formula, which has a square root in it. And so we're going to learn to solve using the quadratic formula. We're going to define what the discriminant is and how we use that discriminant to interpret the number and types of solutions for our quadratic. The quadratic formula, the current version was developed by René Descartes, and while he was the one who's developed the formula that we use now, there was a lot of people before him just kind of paving the way and cultivating the groundwork ideas that helped him develop this formula. He basically took the standard form of a quadratic equation and completed the square on it. And we're going to talk about completing the square on Friday. So it's kind of like a prelude to it. When you use this technique, you want to make sure that you are set equal to 0. Your equation is set equal to 0. You want to identify A, B, and C, and then we're going to write the formula and plug into that formula. The way our homework is set up, we're going to actually be finding the discriminant first, and it actually is an easier way to manipulate this formula. The discriminant is the part that is actually located underneath the radical. It is the b squared minus 4ac. So when we look at that value, whatever it evaluates to be, if it's bigger than 0, we have two options. It can be if b squared minus 4ac is positive, meaning it's greater than 0, and it's a perfect square, then we have two rational solutions. The number is 2, and they're rational. Okay. If it's positive, if b squared minus 4ac is positive, but not a perfect square, then we're going to get two solutions that are going to be irrational, two irrational solutions. If the discriminant is equal to 0, that gives us one rational solution because the number under the radical sign is 0. And then when you take plus or minus 0, just doesn't add or subtract anything. And now that we know complex numbers, if we have b squared minus 4ac is negative, let's write that in, that's negative. If it's a negative number, then we're going to get two complex solutions. So the way we're going to proceed with our problems is we're always going to check to see if we're in standard form. That means that we have to have 0 on one side of the equal sign. We're going to identify A, B, and C. Then we're going to calculate that discriminant. All right, so for our problem, b squared is 36. Minus 4 times 1 times 2, that's 4ac. So we get 36 minus 8 is 28. And so this is positive, so we know we have two solutions. It's not a perfect square, so we will have two irrational solutions. You can just look at that chart. It's also going to be on the top of your worksheet, okay? Two irrational roots or solutions. Now we're going to plug in. We're going to find exact solutions. We're not going to use decimals, so that means we're going to simplify our radicals. So I have x equals negative b, so that's 6, plus or minus the square root of, I've already found b squared minus 4ac, that's 28. Minus 28. I wish I knew what caused that. I really am getting tired of it. all over 2 times a, which is just 2. Okay? Now we're going to go off to the side and we're going to find the simplify the square root of 28, and that is 2 and 14 and 2 and 7. And so we're going to take out this double occurrence of 2 and we're going to bring it out in front as 2, and then we're going to keep the 7 under the radical. So we get x is equal to 6 plus or minus 2 root 7 divided by 2. Okay, so this is the same as 6 over 2 plus or minus 2 root 7 over 2, and so I'm going to cancel. So I get x equals 3 plus or minus root 7. Okay, now because this doesn't have an imaginary in it, we're going to write it as ordered pairs. So I get 3 plus root 7 comma 0 and 3 minus root 7 comma 0. And if we were going to put that on a coordinate plane, we could convert it into a decimal approximation, but we're not doing that. Okay, so we're going to leave it just like that. This next problem, I am not in standard form, so I have to bring the negative 13 over. So I get x squared minus 4x plus 13 equals 0. My a is 1, my b is negative 4, and my c is 13. I'm going to calculate my discriminant, b squared minus 4ac, and I get 16 minus 4 times 1 times 13, and that gives me negative 36. This is less than 0, so I'm going to have 2 complex, that's negative, I'm going to have 2 complex roots or solutions. So that means when I write my ordered pairs, or when I get my solutions, I'm not going to write them as x-intercepts, okay, because they're not x-intercepts. And now I'm going to plug in, and so I get x is equal to 4 plus or minus the square root of negative 36 over 2. The square root of negative 36, that's going to come, the negative is going to come out as an I, and the square root of 36 is 6. So I get x equals 4 plus or minus 6i over 2. The 2 goes evenly into each of those terms, so I get 2 plus or minus 3i, okay, because the 2 cancels into each of them, okay, and so I get, I'm not going to write them as ordered pairs, I get x is equal to 2 plus 3i, and x is equal to 2 minus 3i. While these are solutions, because they're imaginary, they are not x-intercepts. All right, same thing. Check for standard form. Check. My a is 1, my b is negative 11, and my c is 10. I'm going to calculate my discriminant, which is b squared minus 4 times a times c. So I get 121, that's 11 squared, minus 4 times 1 times 10, and that leaves me 81. 81 is positive, so I know I have 2 solutions. It's a perfect square. Perfect square. So that means when you look at that chart, positive and perfect is 2 rational roots. 2 rational roots. Now I'm going to plug in. x equals, the opposite of b is 11 plus or minus the square root of 81 over 2. So that means x equals 11 plus or minus 9 over 2. So that means x equals 11 plus 9 over 2. Which equals 20 over 2, which equals 10, that I'm going to write as an ordered pair. And then x equals 11 minus 9 over 2, which is 2 over 2, which is 1, 0. And those are your two solutions. They're two rational roots. I have one more example. This is where we get one solution. So we're in standard form, check. I have 1, 6, and 9. I'm going to calculate my discriminant, b squared minus 4ac, and I'm going to get 36 minus 4 times 1 times 9. That gives me 36 minus 36. I just plug that into my calculator. That gives me 0. So whenever I end up, my discriminant is 0, that means I have one rational root or solution. I'm going to plug in, and I get x is equal to negative b. So negative 6 plus or minus the square root of, we've already figured this out, it's 0 over 2. So I get x is equal to negative 6 plus or minus 0 over 2. So that just gives me negative 3, 0. Now, if we were to do this by graphing, this would touch and bounce back up and hit the x-axis and bounce back up, right? So we're going to have a worksheet, and if you'd like to get started on it, you certainly may, and I will see you tomorrow.